This is Jack Creel, and I'm going to be going over daily Hurlburt solution to problem 3-20, which is about water boiling in an aluminum pan. We're given the dimensions of the pan, the heat transfer rate, the temperature of the boiling water, and the temperature at the interior bottom of the pan, as well as the thickness of the pan. So we assume that this is at steady state and that no heat is lost. For part A, we need to find the boiling heat transfer coefficient for the inside of the pan. And for part B, we need to find the outer surface temperature for the bottom of the pan. So that'll be the temperature down here, bottom. So she starts part A with the convective heat transfer equation and rearranges it in terms of the heat transfer coefficient, plugs in all the values from the problem statement, and finds it to be 1,253.7 watts per meter squared Kelvin. For part B, she writes the heat transfer in terms of the temperature gradient and the resistance. So this is going to be the temperature gradient over the thickness of the pan, and the resistance will be the conductive resistance of this pan. So she has that written out here. The temperature gradient will be between these two temperatures, and then she subs in the equation for conductive resistance in there, length over conductivity times area, rearranges it in terms of the temperature that we're after, the bottom of the pan, plugs in all the values, and finds this value here. When I originally did this, before going over her solution, I wrote the heat transfer here in terms of Fourier's law. And so when I first looked at it, I thought that might be a problem, but then I quickly realized that as soon as you rearrange it, they're basically the same thing. They're derived from each other, so we end up with the same equation and the same value of 108.34 degrees Celsius at the bottom of the pan.